Now I would like to introduce to you Mr. René Kaiser from Your Name Research in Austria, and he will present some details about FascinatE's second innovative aspect, which is all about content analysis and automatic view preparation. So, René, please go ahead.
Yeah, can you all hear me? Is the microphone working? Yeah, I think so. Before I start the talk, I want to invite people to maybe switch to the other side of the room if that is better for you to be able to see the slides. I'm not sure if you can see them very well. If so, you could do that now. If not, we're just going to start with this. So the next session here, and it's actually the last one before the upcoming demo and lunch session, is about virtual director technology and also content analysis. A brief outline of what I'm going to talk here. I'm going to introduce the idea and concept of a virtual director technology, and I'm going to go into detail regarding the content analysis modules that we have used here in FascinatE. And after that, I'm going back to present more implementation and design details regarding our virtual director. What you've heard already in the talks, mainly in Georg's first talk in the very morning, was that FascinatE is about a format agnostic scene capture approach. By using the Omnicam and also those microphones, we were able to capture the whole scene at all times throughout the production. And that is actually something that is enabling us, as we are interested in new media formats, to come up with new ideas, how to produce media that break this typical broadcast model of producing a single stream that every viewer gets to see. But this is something that is opening up more scope regarding personalization. So if you for a second imagine a sports event of track and field, there's a lot of different things going on, and you might be interested in very, very different aspects of that scene. And such technologies, as FascinatE is researching on, might enable such media formats where you could achieve a very high degree of personalization and everybody could look at those aspects of the scene that he or she is most interested in. But there is a problem with this, because the human production crews cannot really cater for a very high number of individual video and audio feeds in parallel. Just doesn't scale up very well. So this is something we have to tackle here. And we are doing this by what we call virtual director technology. So what is it? In our case, we are researching into software components that can automate part of these decisions. And in concrete terms, they are deciding what is visible and audible at each playout device at each time. They have to take these decisions in real time. Of course, if we have a real-time broadcast situation, would be a little bit more relaxed if it were just using recorded content. And continuously, such a virtual director software will take decisions on how to select between different video viewpoints, how to frame them, how to cut between them, and also when to do that. And of course, the same applies to audio as well. And in taking such decisions, it is influenced by quite a large number of different factors. Of course, you want to see always the most important thing, what's going on in the scene. Sometimes that's not so clear and easy to say which is the most interesting bit that is currently happening. Sometimes it's multiple things in parallel. But also when you cut between different camera views, there is cinematographic principles, aesthetic rules that you want to follow, such that the output that is generated here is aesthetically pleasing. Now, the concrete implementation of the virtual director that we did research on here in FascinatE is, of course, a bit of a slimmed down version of the overall big idea that I just presented. I'm going to present the rough workflow that it takes in terms of its logic. The first point it takes is to try to detect what is the currently most interesting action going on in the scene. The second step is to decide how to frame these actions properly. This might be static things or moving objects or moving actions going on between multiple objects. And the third one, of course, is for each viewer, for each playout device, decide when and how to cut between those virtual cameras. And this all should happen, and we, of course, did not fully implement it yet to full degree, is it should take account viewer preferences, first static ones that are available and are applied throughout the whole broadcast session, but of course as well taking viewer preferences into account during the consumption of the content through some kind of interaction. And the second aspect here is of course to take the playout device into account, and since there is very clever media production people here, I think you're quite aware of what that means. Just a simple example, when you have a fast pan throughout the width of a soccer field and you watched it on a small display, it might look okay, but if you're very close to a very huge screen and you have a very fast pan, that might look horrible. That means that also the display properties in that case have to be taken into account when taking automatic decisions. So why do we do that? One of the aspects, of course, here is to try to save production cost by automating at least some processes of the directing job. Another one is to enable new media consumption formats, and it would be very interesting to talk with you after this session here to share ideas. Maybe you have even better ones than we have. And the third one, to fully replace the human directors and broadcast cameras, broadcast professionals. That's a nice idea for research, but actually that's not really happening. So on this slide, I can show you a little bit of the overall workflow that we are having here. I hope you can all see it quite well. On one hand, of course, you have the microphones and cameras. This is where the content is coming from. We also here at the bottom have a user interface where people can annotate input to the system, metadata about what is currently going on. Then all the media is streamed downstream through the network. The big turquoise box in the middle here is our virtual director. And after decisions are taken and the content is prepared, everything is displayed here on the output playout devices. So this is the rough sketch of how this workflow is going to take place. The virtual director implementation in the FascinatE project has a specific name. We call it the Production Scripting Engine, PSE. And it consists of two different aspects. One, of course, is the software framework. This is something where actually we put most of our research focus on. How can we enable a generic framework that is reusable across production domains? But that's not everything, of course, to the problem. But what you need is the behavior that such a software framework is executing. And you can also split this behavior into two groups. Actually, the smaller one is production rules that are reusable, that are generic. And as we found out, most of the behavior that you want to implement in such a virtual director implementation is very strongly depending on the concrete domain. So if you have a soccer production on one hand and a dance production on the other hand, those are very, very different. So just to get a little bit of an idea, I'm going to switch now to a little video. This is the output of a virtual director. Actually, this was our very first implementation. And what you can see here that, I have to excuse for the bad visual quality, this is just the resolution here. It tries to mainly follow the action. And if you look at this a little bit, you will quickly see some decisions where you can maybe agree that they are quite okay-ish and some which are quite horrible. But that's the nature of research. So something it did just here was to do a transition through a close by region of interest rather than doing a cut. This is something it decides automatically. And I think that's enough for now. So let's continue with the question, how can such a software take intelligent decisions and find out where in the big video panorama are the most interesting spots to look at? It can do that because it's informed through different channels. Those are a database where spatiotemporally metadata is indexed, such that the virtual director can always query it and ask for metadata from there. Also from manual annotations. Actually, this is a design screenshot of a user interface that we were building, at least to some extent. And the third aspect here is automatic content analysis. And already Rob mentioned a little bit of audio analysis, but in the following I'd like to go a little bit more into detail regarding two specific video analysis modules, and the first one is person detection and tracking. So what this does, of course, it tries to detect all the persons that are visible in the scene and also to track them over time. You might be quite familiar with related research and products from this domain. I think everybody who has a small digital camera has seen face detection algorithms being applied there, and actually they're working quite good. So you might now ask, why is this research? Why is this not so trivial? Well, actually, you have also heard in the presentation about acquisition how big the data volumes are that are being produced and processed there in real time. And this is actually, I think, the most crucial challenge that we are facing here. And the solution we applied in order to make this thing real-time capable was to take the individual tiles of the Omnicam panorama image and to build an architecture where these tiles are in the first step analyzed separately. It's called the region tracker, and only after those tiles are in parallel analyzed in real time, they are fused. These results are fused in the second step. So what is the main challenge for the second step? It's of course people who are moving from one tile of the image to another when they are just running from one end of the field to the other. Then you have to somehow keep track of those individual people and hand over the tracking ID from one tile to the other. And this is an image here that is showing how the tracking for one specific tile is working. What you see with red color here at the top and at the bottom is that we applied a mask such that we only look for people in the regions of the image that are of interest. In that case, people in the audience are not interesting to us. We're only looking for players in the soccer field. And I'm not sure how many people here are somehow familiar with video analysis techniques. We applied here a number of different modules, including fast talk implementation and the blob detector from the OpenCV, and combined it with a feature point tracker in order to detect the persons in the scene. Now, what is the most challenging aspect that you have to take into account here? Of course, if you have a single point of view, a single camera position, you cannot expect the person tracking to detect the persons and track them over time 100%, because occlusions eventually will occur. And this is something you can not really handle very well, but we did a rather good implementation here such that we at least try to keep track of the people when there is occlusions happening for a short period of time, by trying to take their movement into account. We also did person tracking on the region of interest cameras, on the broadcast cameras, the moving ones, we applied a very different approach here based on background subtraction. So this is a second set of person tracking technology we did there. So next I'm showing a little bit of a video again. Such that you can get a little bit of an idea how good this is working. You can see bounding boxes across the people. You even see the IDs, the number above them. The camera movement you can see right now was manually steered. So what you can easily see that it's working quite good. It's working better for people who are closer to the camera than those who are far away. When there is bunches of people very close to each other, it's not working that well, of course. But the quality that we were able to achieve here was good enough for the requirements that we had. So let's have a look at the next content analysis module, which is visual saliency estimation. Also something that we aim to extract automatically. What is visual saliency estimation? We are trying to detect regions in the big panorama that humans might tend to focus on because for whatever reason they're somehow salient and interesting. We started our algorithm by looking at how saliency can be extracted from still images, which is of course rather different from what we did here. And then we extended this approach to moving pictures to video. So I'm taking you through some steps through the idea and the process how this is done. At first, we start with a still image of the video. We are doing a grayscale of this, and then we are scaling down the still image into 7 different sizes, so that they shrink and blur by a constant factor through that process. And what we then get is 7 different images from the same frame, where you can compare the top 3 images of them with pairs from the following. And this is enabling us to compute difference values, which you can add and visualize. And if you visualize them, what you get is what you see here on the very bottom is for a static image, a visualization of where the most salient, most interesting parts of the scene are. But this is of course only so far for a still image. So what we have to do now is to extend that to video. That means what is salient is not so much depending only on what is currently visible in the current frame, but we have to take the history into account such that we find out what is salient over time. And for that purpose, the images are split into different blocks. And for these blocks, we are comparing the changes over time. And based on that, we are computing regions of interest. So another very short workflow visualization. We start with a gray image. We compute the saliency maps, where you can see there is some areas where you can find out that there is something like a blob, which you can visualize, as you can see here with this red bounding boxes. And in order to make this really usable for the whole production process, we aim to stabilize these bounding boxes such that we have salient regions here which are stable enough to be eventually used as virtual camera views later on. So I'm showing another little bit of video here. what you can see here in the top is the original image, and on the bottom the corresponding image with the most salient regions visualized with red bounding boxes, and the more salient the saliency value for a concrete part of that grid is, the lighter the color appears. So you can see that the bounding boxes are quite stable, but maybe not stable enough yet to be used as virtual camera views. And if you're interested in more of that, the demo will start right after this talk. So let's come to the last part of this presentation, which is going even more into detail regarding our implementation of our virtual director, the production scripting engine. Actually, from a software standpoint, there is a number of approaches you could take in order to implement such an engine. We had a look at the number of them. For example, description logics, ontologies. This is something that is very expressive, but also not very real-time capable for our purposes. I guess a lot of people here have heard about machine learning-based algorithms and their advantages. This is something we decided not to use here because it's very difficult for our concrete purposes to construct test data sets, to train our virtual director, and also then to tweak an existing behavior once it is trained. So what we eventually chose to do was to use a rule-based event processing approach. And why? Because it's very fast, and because we found out that working with different sets of production rules is actually a quite natural thing to do for this kind of job we have at hand. If you're interested little bit more in technical terms, we were using a library called JBoss Rules, which is both an event processing engine. Maybe you have even heard of the term complex event processing. So this is a technology coming from the financial businesses from trading with shares. This is a technology we use as our basis that is enabling us to take very, very quick decisions because our real-time requirement for live production, of course, is very strong. And also the hooks we have here into the real-time event stream that we are analyzing is structured as event condition action rules. And this is something that we're using here as well. I guess most people here are familiar with some kind of MPEG standard. How many of you are familiar with MPEG 7? Could you raise your hand? At least a couple. So you might want to have a look. So this is the standard here that we used for exchanging the metadata between our components. Something that, of course, is a very nice thing to do in research, such that also other partners could eventually integrate with your data here. One of the concrete challenges we have in building virtual director technology is how to come to the production grammar for a concrete domain. You can't just go to a number of professional directors and just download somehow their wisdom and their creativity to some kind of database. But you have to construct this piece by piece. You have to take the pragmatics of each domain into account. What is the most important thing you want to have a look at? And of course also the aesthetics. How do you cut? And this is also something that is varying very strongly across the domains. And something at least we didn't really find a standard to work with here is we didn't find a standard on how to formalize such production behavior other than natural language, which of course computers cannot really read and process. But if anybody has a clue here or ran across some piece of work where people tried to actually formalize the creative processes, the principles that directors are working with, please talk to us afterwards. So what we did here in order to implement that is we came up with a set of production rules in event condition action format. And we were using models behind them in order to share this common model of that domain across the subcomponents of our virtual director implementation. Another question that is immediately popping up when you think about this domain is how reusable is that behavior? And that is actually very, very difficult, we found out. So we had 3 demo productions so far in the FascinatE project. You've seen some bits of them in the talk so far. The first one was a soccer match, where of course it's rather straightforward to find out which is the currently most interesting spot in the overall video panorama where most people would want to look at. The next one was a dance performance we filmed in the Arena concert hall in Berlin last year, where there is a lot of different things going on in parallel. I think there was something like 100 of dancers performing in parallel, where it's very, very difficult to find out where would you want to look at, how would a human director cut such a scene, and how would a virtual director's behavior want to react to that. And actually we had a third production, which was a very nice concert of the BBC Proms, which was a very nice scene, but very little movement in the scene, why we thought this is very little scope for a virtual director to work with that here. Another implementation challenge we're facing here is the bridging of the so-called semantic gap here. So on one hand, you have low-level information about the scene, the tracks of the persons, the saliency values, some manual annotations through our user interface. On the other hand, you have production rules who decide when and how the virtual director should cut, but there is some kind of semantic gap between them. The rules are quite high level, are based on some kind of understanding of what's going on. The sensors are low level, so what you have to do here is you have to bridge that semantic gap to some extent. And this is something we did with the same technology as we did for this decision-making process. I already explained a bit. This is something where we are inferring through semantic abstraction from the low-level queue stream, more high-level concepts, which we can later relate to the rules that we apply. The technology that we are using is very, very capable of implementing such a virtual director that is able to take real-time decisions. Of course, this is not so trivial. And when you have a large number of rules, of course, at a lot of times, different things are going on in parallel, and you have competing and contradicting principles which have to be resolved in real time as well. And of course, there is a small issue with this, because if you only have rules that are reacting to what is detected, you might always be a little bit behind, at least for some cases. So if you would implement the goal detector for the soccer domain, and then 10 milliseconds after the goal was scored, you would cut the camera to the goal area, that's of course too late in that case. So ultimately what you want to have here is a little bit of prediction. Of course, this is even tougher to do to compete here with the intuition and creative brilliance of the human directors. Another aspect I couldn't resist to put up here is the problem with syncing. When you have a huge production system like we have in FascinatE, this is not trivial to have the right pieces of content and metadata and decisions in place at the right time. In order to have a better overview of what is going on, we developed some monitoring tools that allow us dynamically to look inside the virtual director and to keep track of its state and what it's doing. That's very handy for debugging. And I'm now going to very quickly rush over some slides that are giving you a little bit of an intuition of how the virtual director is implemented. So what you can see in this diagram here is that it is consisting of multiple instances. We developed it in a way that it's a flexible chain of virtual director instances that are working together in order to take these decisions. And you have a primary instance here on the left, which is on the production end, which has direct interfaces to all these metadata streams I explained a little bit earlier. And in this case, you would also have an instance at the terminal end, which would take the viewer decisions into account and take final decisions. And it has a number of sub-processes that I'd like to briefly explain in the following. I already mentioned that the semantic lifting is a challenge. So this is something that is one of the key sub-processes here, to have a direct interface with the metadata low-level streams in order to lift them and move them to a more semantically abstract level. Another sub-process here is what we call shot candidate identification. So this is something where you always want to manage in your technology a list of suitable shots that are available at all time, such that you can dynamically choose from them. And this list should never be empty. Another important sub-process here is the shot framing. When you have an object that somehow you found out that this is salient or interesting and you want to put a virtual camera on that, you have to decide how to frame that. And of course, this is rather straightforward and simple for static objects, but it's quite a challenge for moving objects. What we did here is we used a kind of a spring-based approach to smooth movements when we follow moving objects through the scene. And of course, the most challenging and critical subcomponent of the virtual director is the actual decision making. So one more little video. Of a virtual director from a dance performance. The same applies here. You will see some cuts and decisions that you would think are quite okay and some which are rather horrible. Fast pan on a big screen which you're close to can be an issue for big screens. Same decision for a small screen might look okay. There was some kind of jump cut involved here right now, which was of course not very good. This is of course also something where the people are not properly framed in their head in the image. But I think you get the idea. There's some things you can do, some things that are very, very difficult. And if you're interested, the demo of this will start right after this one. So to conclude the talk, I'd like to talk a little bit about the limitations of such an approach. Of course, we cannot really compete with the creative brilliance and intuition of a human production team. So if you compare only the decisions on a single video stream that is coming out of this, there is some things you can automate. There is some things where a lot of more research is necessary to do that. I talked about the semantic lifting, the automatic understanding of the scene, which is quite a challenge. The whole engineering of a behavior for a certain domain is, of course, also a challenge because it involves a lot of effort. And when you have a large number of principles which are in a concrete situation competing and contradicting with each other, this is something where also we are putting some research on because it's not that trivial. So regarding the effort it takes, I'm not sure if how many of you are familiar with the XKCD comics. This is something that is probably explaining that to the point. So in summary, what we achieved here is we were able to implement a software framework capable of performing virtual director decisions in a framework that is quite reusable for different production domains. We were able to fulfill requirements regarding the real-time performance, which is actually not that trivial. And at least we have a prototypical behavior for two production domains. As you have seen, they're not perfect, but they're good enough for the proof of concept. And the full system integration is still in progress. There will be an event here in Salford in May, which will be introduced later, where we actually will try out the live demo. You're of course very welcome to join this. We are currently working on evaluation of this, which is of course quite a tricky thing to evaluate a piece of software that is kind of replicating a creative process where there is no real right and wrong. So we are working on that. And there is many open challenges that we are facing and we are happy to tackle in the future. So as the last bit, I'd like to invite you to see the demos which are coming up next. The virtual director will be here over there in a couple minutes. And there is also an evaluation session going on, which Louise and Gert, can you raise your hands if you're here? We'll be conducting in a couple minutes. So if you're happy to see a little bit more, please join us and help us a little bit with the evaluation session here. So thank you very much.